Hello guys, Cyprien from FU of All. This will be a short video but very insightful, hopefully. So what I'll teach you in this video is how you can extract some results from Code Aster in a text file format in the easiest way. Because the problem you have often with Code Aster is that it generates a met file in which you have to have paravis to open it and then find the data you want. So it's a lot of steps to finally do something simple. If you just want one data at one point, like the displacement over here, and you don't necessarily need to want to go to paravis every time, you just need the value of this point. There are much more easy way to do it, and this is not explained very clearly anywhere on the internet. So when you go on the internet and search it, well, you can find some hints on how to do it, but it's not very well explained. So my purpose of this video is to start from this model. So this is the nonlinear spring, for which I've made a full video showing you how I simulated that. So it's a nonlinear static simulation with nonlinear material and contacts. So the first thing I'm going to do is to create a node here, a node group. So I'll have to come back to my mesh, and so this is my mesh, and I've basically created a group of node with only one node into it, and this will be the position where I want to extract the displacement in the y direction. So once you have done that, so it's pretty easy to create a new group. Just go here and create group, select the node you want to add to the group, and you have it. Now in Code Aster, so what you have to use is this function of post-processing. So it's called post-relevé t. So this is the function that we will use to create a table of one specific type of result. So I'll give that a name. I'll call that displacement at A1. So this will be the name of this command. The action we want to have here is so first activate the result. So this will be result from this this command. Select the node, so the node group I just created. The operation we want to do here is to extract something, so it's extraction. The field we want to work with is the displacement, and I don't want all the displacement, so I just want one specific field of the displacement. So I will add a nom champ, so field name here, and I want to extract the dy component of only. You can extract several components, that's not a problem. Here you have to give a name, so you can write everything you want here. So this will be, I don't know, dy extraction. Okay. And they are all the parameters. So for example, if you want to extract only the last time step, you can, for example, check this option inst and then give it a value. So time step 1, I'll just put 1 here. Well, in my case, I will extract all the time steps. So that's all I need. That's all I need. So okay. And this is not enough. You have this. So what this does is that it creates a table, but you have still to put that table to a file. So after you do the imp Rusu, you go again and you do a, where is it, imp table. There should be another command. Okay, it's hidden here. Imp table. Yeah. So you do imp table. You select this table coming from this function. You give it a name. So I'll just call that dy table, and give it the extension txt. Okay, and that's all we need to do. So now I'm going to show you the result of that. I will run this simulation. So it takes a bit of time, so I'll just pause here and come back when it's finished. Okay, so my simulation is now finished. So let's have a look at the file generated. And you see that I have dy table txt. So if I open that, the result will be presented in a table like this, in a text file. So you have your dy result are in this column, and here you have the coordinates of the node and the position that I have taken. So very useful way to do this. Now, if your problem is to obtain those results, but while you are doing the simulation, so you want to do some real-time monitoring, you have several ways to do it. The first way is, like I have shown during the tutorial, is to go in the stat nonlinear and use this suivi DDL option. So you use suivi DDL, you click here, and this you input the node group you are following, the field here. Here this is the dy component of the field, and this is what you want to do with it. You want the value. Now if you do this, this will give you the value while you are solving. So you will see it printed in here in the last column of the Newton iteration. So this will be the value of the suivi DDL. Now if you want to print that into a file instead of using this suivi DDL, it's also possible, and you have to use another method. So let me show you. You go in stat nonlinear, instead of using suivi DDL, so you can still use it at the same time, you have to use this observation. So check that, and this observation will create a table that you will be able to save to a file. And the file will be automatically reloaded while you are doing the simulation, so it's pretty useful. So if I do, so the field will be displacement. I want it at my node A1. I want only dy component, right? And I want the value. Okay, so that's everything. So, but that's not all. This is a bit more complex than suivi DDL. If you do that, you have to go into I think it's output, and you have Rusu table, so which means receive table. So, and this will be, you will have to link it to the observation table that you have created. So the name of the table should be written here as observation, and here you should choose the result. So this, like that, yeah. If you do this, so I can call that OBSV, for example, and it's still not enough. Once you do that, you need to use again the imp table. So I will use the same imp table here, but instead of using the post relevete that I've shown you, you have this obs table that I have created. And let's try that. So let's reload and let's start to solve. So the difference of observation with suivi DDL is that you can see the suivi DDL here while it's simulating, but observation will be only printed to the file at the end, because the command imp table is only appearing at the end of the simulation. So that's the difference if you want to print everything but at the end. So it's pretty much similar to the post relevete method. Now the simulation is over, let's have a look. So my file was created, and this is what you get. So each exported time step, so I have 30 observations. For each of those I will have the instant, and I have also the value of the displacement for this specific time step. So that's pretty useful. And that's it for this video. That video was pretty short, so I hope you liked it. If you do, please give it a like, let me know, and post a comment. Thank you very much for watching.